273 Kelvin degrees.
So, if delta S equals Q over T, then delta S is measured in joules per Kelvin. Let's try out this new knowledge in an example.
Find the change in entropy when 0.2 kilograms of lead melts at its melting point of 327 degrees Celsius. If lead has a latent heat of fusion of 2.45 times 10 to the 4th joules per kilogram.
To solve this problem, first we have to figure out how much heat it takes to change the solid lead into liquid lead. Remember your insert card and see that the equation for the amount of heat needed to go from a solid phase to a liquid phase is heat equals mass times the latent heat of fusion. Q equals m times L sub F. That's 0.2 kilograms times 2.45 times 10 to the 4th joules per kilogram, which is 4,900 joules.
Now that we know how much heat it takes to change the phase from solid to liquid, we can find the lead's change in entropy using our equation delta S equals heat, Q, over temperature, T. Remember that the temperature in this equation is in kelvins, so first we have to change 327 degrees Celsius into degrees Kelvin.
The temperature in degrees Kelvin equals the temperature in degrees Celsius plus 273. Using our information, that's 327 plus 273, which is 600 degrees Kelvin. Boy, that worked out to be a nice round number.
And filling into our equation for the change in entropy, delta S equals Q over T, we get that delta S equals 4,900 joules over 600 degrees Kelvin, which is 8.2 joules per degree Kelvin. So, that's the change in entropy when those 0.2 kilograms of lead change from a solid to a liquid.
The first law of thermodynamics states that the change in the internal energy of a system equals the heat added minus the work done by the system, or delta U equals Q minus W. An isovolumetric process is when there is a gas and the volume is kept constant, but the pressure can change. An isobaric process is when the pressure is kept constant, but the volume can change. And in an adiabatic process, no heat is added or taken from the system.
The second law of thermodynamics states that heat flows naturally from a hot object to a colder one, and heat will not flow spontaneously from a cold object to a hot one.
Heat engines turn heat energy into electrical or mechanical energy. The heat from the hot reservoir equals the work done plus the heat from the cold reservoir, and efficiency is work divided by heat. Another way of stating the second law of thermodynamics is that the efficiency of a heat engine can never equal 100%.
Entropy is the measure of disorder of a system, and the change in entropy equals heat added to a system divided by temperature, or delta S equals Q over T. And a third way to state the second law of thermodynamics is to say that the entropy of a closed system can never decrease. It will always increase as work is converted into heat. So smile, that was the last thing, and it looks like you made it.
Hey, thanks for watching the Gravity-Packed World of Physics Part 2. We know we've gone over everything from energy to entropy, but you can always rewind the tape, take a peek at the insert cards, or you could even watch the Gravity-Packed World of Physics Part 1.
After you've looked at physics, check out other tapes from the standard Deviants, like astronomy, English composition, statistics, French, and much, much more.
Now, if you have any questions,
Or you just want to call to say hello,
please give